looking here at tangents to circles. We're looking a little bit closer at what's some special facts about tangents. The main one we want to deal with today is that if a line is tangent to a circle, then it's always going to be perpendicular to the radius, where an endpoint on the radius is the point of tangency. It says here, if a line is tangent to a circle and the line is perpendicular to the radius drawn to the point of tangent. Wow, I just said that without even looking at that. We can see right here, doesn't it make sense? We see the tangent line, we draw the radius to it, and it's going to be at a right angle. It's going to be perpendicular. Any circle you draw a tangent line to that guy. You see the point of tangent, see if we connect that to the center of the circle to form a radius. You know what? That is forming a right angle. So that's the main theorem today. Here it says, sketch circle C, line N is tangent to circle C. Ooh, not the best drawn line. Line N is tangent to circle C. At point P, and line M passes through C. Lines M and N intersect at point Q. So I have this other line M. These intersect at point Q. And this was point P over here. So we have points C, P, and Q. So we've sketched this out. We marked C, P, and Q on our sketch. Made sure to do that. And we know when a radius intersects the point of tangent C, it's forming a right angle. So it's also forming a right angle right here. If angle CQP is 36 degrees, CQP right here is 36 degrees, we want to find PCQ. We want to find the third angle to our triangle. Well, we can do that. The triangle angle sum theorem, we add up all three. They should all add up to be 180. And when we work through that, we see that this angle must be 54 degrees in order for all three angles of this triangle to add up to be 180. This next theorem says that if the endpoint of a radius ends up being perpendicular to a line, that line is guaranteed to be a tangent. Next theorem says if two tangent segments, no, it's not just tangent lines, but we're talking about tangent segments where they have two endpoints, are drawn to a circle from the same exterior point, they're always going to be congruent. Point Q, exterior point, tangent segment to M, tangent segment to N, those two segments are congruent. Okay? So in this figure, JK and JM are tangent to angle or to circle L. Well, if they're tangent, we know they're forming right angles with the radius. We also know since they're coming from the same point J and they're tangent to the same circle, they must both be the same measure because they are congruent. If LM is 8 inches and LM is a radius, then this other radius is also going to be 8 inches. So we add up all four sides. That would be 16 plus 17 is 33 plus another 17. The perimeter comes out to be 50 inches. It says, what type of quadrilateral is JKLM? Well, it's not a parallelogram. Notice that we have two congruent sides. We have another two congruent sides. Those are consecutive congruent sides. This is a kite. Here we have an ornamental window. Has several glass panes oriented to look like an eye. The radius of the iris is 3 feet. Okay, we can see that right there. DC is 5 feet. What are AI and AH. We want to find AI right here. We want to find AH right here. Well, first of all, we know they're going to be the same thing. If we find AI, we found AH, they are the same answer because these are both tangents coming from the same exterior point to the same circle. So if we can find AI, we can find AH. They're the same thing. Okay, so let's think about what we can use here. If I were to draw this line right here from A to F, notice how this line is the same as DC. In fact, it is parallel to DC, it's congruent to DC, because this forms a rectangle right here. And the opposite sides of a rectangle are congruent. So this right here is 5. And we have a triangle right here, and it is indeed a right triangle because we can see that that right angle right there, one side's 3, the hypotenuse is 5, that means this side must be 4. Think about that for a second. See how we got that 5 as a 3, 4, 5 right triangle? So the missing side is 4. Both of those missing pieces would have a length of 4 feet.